What we're working on in the second part of section 6 of chapter 8 is solving applications that involve rational equations. So these story problems are going to result in a rational equation, which means we'll have fractions with variables in the numerators and or denominators. So I want to start out by talking to you about proportions. We'll fit it in right here. A proportion is when you have a ratio equal to another ratio. Now, ratio means a comparison of two numbers, which can be written with the little colon between them, or it can be written as two fractions equal to each other. And that's the type that we're talking about here, is when you have two fractions equal to each other. And in order to solve a proportion where you have two fractions equal to each other, what you're going to do is cross multiply. So we're going to multiply the D times the A and set it equal to the B times the C. And we'll see that in some of our problems here. So let's start on our first example. On a map, the distance from Ottawa to Lawrence is 3.7 centimeters. You know that it is 26.1 miles in real life. On the same map, it is 35 centimeters from Ottawa to Des Moines. About how far would the drive be? So we've got Ottawa and Lawrence. It is 3.7 centimeters and 26.1 miles. And then Ottawa to Des Moines, it is 35 centimeters, and we don't know how many miles, so we're going to say x. Since it's an unknown amount, we'll use x for our variable. Now, when you set up your proportion, it's very important that the numerator and denominator match each other on both sides, and also that the numerators match each other and the denominators match each other. I'll show you what I mean by that. When I write my first fraction or ratio, I'm going to make a comparison of the two pieces of information from Ottawa and Lawrence. So if I want to say 3.7 centimeters over 26.1 miles, then these two match because they're both information about the Ottawa-Lawrence situation. Now on the other side, these two are going to match because they will both be information about Ottawa and Des Moines. However, my two numerators need to match. So how do I make that happen? So if I'm going to make my two numerators match, notice that this is the map distance, which is 3.7 centimeters. So this numerator also needs to be map distance, which is 35 centimeters. And then the denominators need to match. This denominator is the real life distance, 26.1 miles. And then this denominator needs to be the real life distance, which is x miles. Now, could I have set this up differently? Absolutely. I could have put 3.7 centimeters matching with 35 centimeters and set that equal to, so then we got to be careful to match. We have centimeters, centimeters. So this is our map distances, which means this will be our real life distances, but the numerators need to match. And since 3.7 centimeters was my Lawrence and Ottawa information, then the numerator here needs to be the 26.1 miles. And the denominator, the 35 centimeters, needs to go with my Des Moines information, so x miles. I could also have had both of these fractions flipped or both of these fractions flipped. So there are 4 correct ways to set up each of these proportions, and there's like 2 incorrect ways. So just be careful when you set them up, and odds are you're going to be correct. So once we have our proportions set up, we're really going to be ignoring the units So most of the time I don't write the units in. I just did that so that you could see how everything needs to match. And now we're going to cross multiply to solve. So I'm going to go like multiply this direction. So I have 3.7 times x equals, and I multiply this direction, 26.1 times 35. And then I will need a calculator to do this multiplication. So I'll do 26.1 times 35. So I have 3.7x equals 913.5. And then to solve for x, just divide both sides by 3.7. Divide by 3.7. And I get x equals 246.8918. So depending on how many decimal places the problem is going to ask me for, this one didn't ask me, though it told me it was 26.1 miles. So I could say that it would be about 246.9 miles from Ottawa to Des Moines. Okay, our next problem. If your car gets 23.7 miles per gallon, how much gas will you need to get to Des Moines? So we're going to use our miles from here to help us with that problem. So part A is that. Part B is how much will it cost us to drive there. So let's work on part A. My car gets 23.7 miles per gallon. Now the word per in that statement is indicating a ratio already. So it means that we have 23.7 miles. Per means like divided by or for every. For every how many gallons? For every 1 gallon. So that's already setting up our ratio. So that's going to be equal to how many miles do we need to go to Des Moines? 246.9. So 246.9 miles. And we don't know how many gallons that's going to take us, so that's going to be x gallons. So we have this proportion that we're going to solve by cross multiplying. Remember that we don't usually write our units in there. I'm just doing that to help us out to get things set up correctly. So we can ignore all of these units and then go ahead and cross multiply. So we have 23.7 times x equals 246.9 times 1. So I'm not going to write that times 1. And then we can just solve by dividing both sides by 23.7. Let's see what that gets us. 246.9 divided by 23.7. Looks like we are going to need 10.41772152. So let's just go ahead and round that to a reasonable amount and say 10.42 gallons of gas. Now part B wants to know if gas is $1.74 per gallon, how much is it going to cost us to drive to Des Moines? So here we have another ratio, $1.74 per 1 gallon is equal to, what we don't know is how much money, so x dollars, and we have 10.42 gallons. Now we have that ratio again, so we can cross multiply. So we have 1.74 times 10.42 equals x. That's a pretty direct solution. So 1.74 times 10.42, 18.1308. So it's going to cost us $18.13 to drive to Des Moines. The next type of problem we're going to start is a new setup. It is working together. So we're going to write some information about working together down here. And there's a specific way to set up a working together problem. It's going to be 1, which is how many jobs you're completing, divided by the time it takes person number A or machine number A or whatever two things you have working together are going to be called A and B, plus 1 divided by the time it takes person B working by themselves. So the time it takes A working alone plus the time it takes B working alone is equal to 1 over the time it takes A and B working together. Now there are some different varieties of these problems that you might run into. Sometimes it will say it takes the second person twice as long. So if it takes somebody twice as long, then we would do 2 times however long it took person A. So it takes B twice as long, you would do 2 times A. Or it might say something like it takes person B 8 hours longer than it takes person A. So if it takes 8 hours longer, then we would do person A plus 8. So that's just a little helpful information you might need later. But we're going to do this problem here with the working together formula. I can paint my kitchen in 3 hours. Bob can paint my kitchen in 7 hours. How long would it take if we worked together? So I have, for me, it takes 3 hours. For Bob, it takes 7 hours. And I want to know how long it takes us together. So looking at my formula, 1 divided by the time it takes person A alone. Well, that's me, so 1 over 3, plus 1 over the time it takes person B working alone, that's Bob, 1 over 7, equals 1 over the time it takes A and B together. Well, we don't know that, so we're going to use the letter x, equals 1 over x. Now this is one of those rational equations that we've been talking about. So what we want to do is clear those fractions so that we don't have to deal with them. So we're going to work kind of a piece at a time. In order to clear the denominator of 3, I need to multiply each of my terms times 3. So that will cancel out that 3, but I still have 2 other fractions. So I also need to multiply each times 7 to cancel out that fraction. So that cancels out that 7, but I still have a denominator of x. So I also need to multiply each one times x, which will allow me to cancel out that denominator. So what we have left in this first term is x times 7 times 1, so 7x, plus x times 3 times 1, which makes 3x, equals 1 times 3 times 7, which is 21. Now I have a straightforward equation I can solve. 7x plus 3x is 10x. 10x equals 21. Divide both sides by 10. And we get x equals 2.1. Well, the x was how long it takes us together. So that's going to tell us if we work together, it will take us 2.1 hours. All right, we have another working together problem. Working together, working alone, it takes Fred 2 hours longer than it takes Wilma to finish a puzzle. If they can do the puzzle in 10 hours working together, how long would it take each of them working by themselves? So we've got Fred and Wilma. Takes Fred 2 hours longer than Wilma, and together it takes them 10 hours. So we don't know how long it takes Wilma. So I'm going to be creative and use the letter W for how long it takes Wilma. And then if it takes Fred 2 hours longer, so it would take Wilma's time plus another 2 hours. So that's what we had at the bottom of that page where I gave you that sample about if it takes 8 hours longer. And then we're going to set it up the same way we have been. So we'll have 1 over the time it takes Fred, W plus 2, plus 1 over the time it takes Wilma, which is W, equals 1 over 10. This one looks like it's going to be a little bit more complicated, but we're going to follow the same process to simplify and get rid of those fractions. So we'll go a piece at a time. I need to multiply by W plus 2 to cancel this denominator. So times W plus 2 times W plus 2. Now remember that W plus 2 and W will not simplify because the W plus 2 is superglued together. I'm going to need to multiply by W to cancel the W. So times W times W. And then to get rid of the 10, multiply by 10, by 10, by 10. So then for my first term, I have 10 times W times 1, which is 10W. In my second term, I have 10 times W plus 2 times 1. So that means I'm going to have 10 times W plus 2. And then on the right side, 1 times W plus 2 times W. So W plus 2 times W. Then I'm going to need to distribute this 10 and distribute this W. Even though it's on the right hand side, it's still multiplied, so we're distributing. So we have 10W plus 10W plus 20 equals W squared plus 2W. Now this equation is a quadratic equation because it has a squared in it. And we have a couple of options to solve it. We can factor it, or we can use the quadratic formula, or we could complete the square. But let's be honest, none of you are going to do it that way. You'll either be factoring or using the quadratic formula. So in factoring and quadratic formula, we need to start by getting our equation equal to 1. And in both cases, I prefer to have my W squared be the positive coefficient. So I'm going to move these terms over to the right side. So right now I have 20W plus 20 equals W squared plus 2W. I want to make this equal to 0 over here. So I'm going to subtract 20W and subtract 20. So my right side will be W squared minus 18W minus 20. I can already tell you, just because I've done this problem ahead of time, that it's not going to factor. You can try to factor it, but you're not going to find factors of negative 20W squared that add to negative 18W. It's just not going to work because our only possibilities are 1W and 20W, 2W and 10W, 4W and 5W. None of those are going to work. So we can't factor. So we're going to use the quadratic formula. Which, if you remember, is x equals opposite b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I'm going to work mine up here because I ran out of room. So I'm going to use the letter W instead of the letter X because that's what my equation has. So I have the opposite of b, so that will be positive 18 plus or minus square root of 18 squared, 18 squared, which is 324, minus 4 times a, which is 1, times c, which is negative 20, divided by 2 times a is 1, so that makes 2. So w equals 18 plus or minus square root of something. Well, it's going to be, in that discriminant, 324, and then I have negative 4 times negative 20, so plus 80. 324 plus 80 is 404. Now, since this is a story problem, we're not going to worry about simplifying that radical. We're just going to get the two values. So we're going to do two problems in our calculator. One, we're going to do 18 plus square root of 404 and then divide by 2. So 18 plus square root of 404. Go ahead and hit enter and then divide by 2. So we get 19.05. And then we're going to do 18 minus square root of 404. Divide by 2. We get negative 1.05. Now remember that in this problem, W is how long it takes Wilma. So it cannot take her negative 1.05 hours. So this is going to be the only valid solution that we have. And we can say that it would take Wilma 19.05 hours. And we also need to say how long it would take Fred. Well, it takes Fred 2 hours longer than Wilma, so I need to do W plus 2. So 19.05 plus 2, which would be 21.05 hours. Okay, this is our last problem, and it's a new type. It's a distance, rate, and time problem. We have that a plane travels 100 miles against the wind in the same time it takes to travel 120 miles with the wind. Wind speed is 20 miles per hour. Find the rate of the plane. So we need a new formula for these kinds of problems: distance, rate, and time. The general formula for distance, rate, and time, I remember it by dirt. It's distance equals rate times time. And that's like if you're driving, you know, your rate might be 60 miles per hour. If you drive 2 hours at 60 miles per hour, your distance would be 120 miles. Then we have two different varieties of this. If I wanted to have R equals instead of D equals, I would need to divide both sides by T. So R would be distance divided by time. Or if I wanted to solve for time instead, T equals, I would need to divide both sides by R. So time equals distance divided by rate. So those are our formulas for distance, rate, and time problems. In this particular problem, we have a plane that is flying against the wind and then with the wind. So what happens in that situation, if we're flying against the wind, then we have our plane going one direction, which is going to be faster than the wind. So this is going to be the rate of the object. And I'm not putting plane, I'm putting object because it could be against the wind, against the current. If you're walking on a moving sidewalk, you could be walking against the motion of the sidewalk. But whatever's happening, you're going to have the rate of the object that's going against the rate of the whatever your resistance is. And then when we're going with the wind or current or electric sidewalk, we have the rate of the object and then the rate of the helper, I guess. Because when you're going against the wind, it's pushing against you. When you're going with the wind, it's pushing you forward, so you move faster. So when you have a resistance, it's going to be a negative rate. When you have a helper, it's going to be a positive rate. So what we need to do is we're going to take the rate of our object and the negative rate of resistance, and we add them together. So our overall rate in the situation when we're against the wind or the current is we take the rate of the object and then we're going to add the negative rate of the other thing, the current or the wind, whatever it happens to be. When we are going with the wind or the current, our overall rate is going to be the positive rate of the object plus the positive rate of the helper. Okay, so that's your general setup. Now let's do the actual problem. We have a plane that is going against the wind, and then it's also going with the wind. So I'm going to set up a little table that's going to have my two situations, against the wind and with the wind. And I'm going to have a column for distance, rate, and time. Okay. A plane travels 100 miles against the wind. So we have against the wind 100 miles. Travels 100 miles against the wind. So that's 100 miles in the same time that it takes to travel 120 miles with the wind. So 120 miles with the wind. Now this part where it says in the same time, that is important. That means that these two things are the same. The times are equal. So let's look at our rate. It tells us that wind speed is 20 miles per hour, and we're supposed to find the rate of the plane. So let's go ahead and make the rate of the plane P. And we know that 20 is the rate of the wind. Now when we're going against the wind, that rate of the wind is going to be our resistance. When we're going with the wind, the rate of the wind is going to be our helper. So when we're going against the wind, we want to take the larger rate of the object, which is going to be positive, plus the negative rate of resistance. So we're going to have the larger rate of the object, P, plus negative 20. Now that looks a little bit awkward, so probably I would just write it P minus 20 when I'm doing my problems. When I'm going with the wind, I have positive rate of the object plus positive rate of the helper, so P plus 20. Now here's where it helps us that the times are equal. Instead of writing distance equals rate times time, I'm going to use this version of my problem, that time equals distance divided by rate. So for the against the wind, the time is going to be the distance, which was 100, divided by the rate, which was P minus 20. When I'm going with the wind, it's going to be the distance of 120 divided by the rate of P plus 20. And then I can set those two times equal to each other. So I have the 100 divided by P minus 20 equals 120 times P plus 20. Now this looks like one of those ratios that we started out with at the very beginning of our notes today. So I can solve that by cross multiplying. So I'm going to cross multiply here. 100 times p plus 20 equals p minus 20 times 120. And then I'm going to distribute. So 100p plus 2,000 equals, distribute over here, 120p minus 2,400. And then we'll solve this. I want to move all my, it's a linear equation, so I'm going to move all my variables to one side and move all my non-variables to the other. I have to finish up here. So I have 2,000 plus 2,400, so 4,400 equals 120 minus 100, 20p. Divide by 20. $4,400 divided by 20 is 220. So P equals 220. And that is the rate of my plane. So I can say the plane is flying at 220 miles per hour. Now sometimes they mess with you and say find the rate of the plane in still air, and that just means how fast is the plane going. You'll see that a lot of times with boats. The boat can go however much in still water. Don't let that throw you off. It just means the speed of the plane or the speed of the boat.